Now let's proceed to vector addition and subtraction. So let us suppose that a car moves along a straight line and we have two vectors, A and B. So the first one, we have a vector that is equal to 275 meters due east, and vector B, which is 125 meters due east also. Notice that these vectors are pointed to the same direction. So if this is the case, we can simply add them to find the resultant vector R. So 275 meters due east plus 175 meters due east, that is equal to vector R, 400 meters due east. Let's proceed to the next case if the vectors are perpendicular to each other. So again, we have vector A, which is 275 meters due east, and we have vector B, which is 125 meters due north. So we have vector R as the resultant of these two vectors. So we have to arrange these two vectors in a tail to head fashion. So this is the arrangement. So notice that we formed a right triangle. So we can use the Pythagorean theorem to solve for the vector R. So for the magnitude of the resultant vector, we'll use the Pythagorean theorem. That is 2 square root of 275 meter square plus 125 meter square, that is equal to 302.08 meters. So that means the magnitude of vector R, or the resultant vector, is equal to 302.08. As for the direction, we can use the arctangent function. So this is the arctangent of the opposite side over the adjacent side. So that is the arctangent of 125 meters all over 275 meters, which is equal to 24.4 degrees. So thus we can say that the resultant displacement of the car has a magnitude of 302.08 meters and points northeast at an angle of 24.4 degrees. So sometimes we add vectors that are not perpendicular to each other. So since they are not perpendicular, we cannot use the Pythagorean theorem and the inverse tangent function. So one option here is we can use the graphical method. In the graphical method, we draw the vectors using a ruler for its magnitude and a protractor for its direction. So for the magnitude, you can use the scale. So for example, 1 meter is equal to 1 centimeter and so on. But you can also use other scales which is more convenient to you. And for the direction, we will use the protractor, which has the equivalent angles. So once you have drawn the two vectors, you can draw the resultant vector and you can measure its length to find its magnitude, and using a protractor too, you can find its direction. So another method which we can also use is adding vectors by means of the component methods. So this simply means that we have to get the component of each vector and add those components. So for the x component of the resultant vector C here, we will just have to add the x component of the vector A and the x component of the vector B. So the same for the y component of the resultant vector C. So we have to get the y component of the vector A and the y component of vector B. So if we add those two, we will get the y component of the resultant vector C. And so after we found the x and y components of the resultant vector, so you can now use the Pythagorean theorem and the inverse tangent function to solve for its direction. So let's try to solve example problem 1.5. So 3 players in a reality TV show are brought to the center of a large flat field. Each is given a meter stick, a compass, a calculator, a shovel, and in a different order for each contestant, the following 3 displacements. So they have vector A, 72.4 meters, 32 degrees east of north, 57.3 meters, 36 degrees south of west, and 17.8 meters due south. So the 3 displacement lead to the point in the field where the keys to a new Porsche are buried. 2 players start measuring immediately, but the winner calculates where to go. So what does she calculate? So for this solution, let us draw the figure. So have the figure here. This is vector A. So this is 72.4 meters. That is the magnitude. And this is east of north. So we have north as the reference. So we are going east. So the angle is measured in this manner. As for the vector B, that is 57.3 meters. This is the magnitude south of west. So we have the west line here and we are going south. So this is the 36-degree angle. And as for the last vector, we have 17.8 meters due south. So this is 17.8 meters and it points due south. So notice that the resultant vector is positioned in this manner. So again, we start from the tail and to the head. So this is the resultant vector R. Now to solve for the components of this resultant vector R, we have to get the x components of vectors B, A, B, and C to get the x component of the resultant vector R, and in the same manner, get the y components of vectors A and B, A, B, and C to solve for the y component of the resultant vector R. So first, let us assign some value, sign conventions. So we have north as positive. We have the south as the negative. Let us set east as the positive x direction and the west as the negative x direction. So, for vector A, so, okay, let's denote the x component of vector A as A sub x. So, A sub x is equal to the sine of okay, so we have 72.4 meters as the hypotenuse, and we are going to use the sine functions since the x component of this vector is opposite to the 32-degree angle. So, times sine 32, 0 degrees. So, as for the y component, we have 72.4 meters times cosine 32.0 degrees. So, calculating, we have 38.37 meters. So, the x is, so this points the east. So, this is positive. So, 38.37. So, this in meters. As for the y direction, we have cosine 61.40 meters. So again, the y components is directed to the north, so we'll take it as positive. .4. Let us first write the components, the distances here. So 17. Okay, so for B, so the x component first, we will use, since the angle is in here and we are going to get the x component, we will use the cosine function. So for the hypotenuse, that is 57.3 meters times cosine 36 degrees. And for the y component of the vector B, we will write 57.3 meters sine 36 degrees. So, let's compute 0.3 cosine 36. This is equal to 38.27 meters, and vector for the y component, we have the sine so let me correct this one. Mali ang aking input sa calculator. So again, 57.3 cosine 36. This is equal to 46.36. This is equal to 46.36 meters. And for the sine, 33.68 meters. So let's put this into the table. So notice that the x component is directed to the west. So we will take that as negative 46.36 meters, and the y component that is directed to the south. So that is negative 33.68. So as for vector C, so automatically this is equal to 0 since the vector C points to the south. 0, and the y component, this is equal to 17.8 meters, but it also points to the south, so we'll take this as negative 17.8 meters. So we will just get the sum. So 38. So when solving for the sum, you have to consider the signs. So 38.37 plus negative 46.36. So this is equal to negative 7.99 meters. And for the y component, we have 61.40 plus negative 33.68 plus negative 17.8. So this is equal to 9.92 meters. So let us check if we have the correct signs. So the x component is negative, meaning it points to the west. So this is, yes, it points to the x component of the resultant points to the west. And for the y component that is positive, it means it points to the south. So our computation is correct. So now let us solve for the magnitude of the resultant vector. So the magnitude R is equal to the square root of the sum of the squares of the x and y components. So again, we have negative 7.99 squared plus 9.92 squared. So the resultant is equal to square root of negative 7.99 plus 9.92. So this is equal to 12.74 meters. And as for the direction, theta, we have the arc tangent of So we will get the angle here. So we have the so para hindi kayo ma-confuse, ito na, itong angle na to ang kukunin na natin. So if the angle is located here, we have the x component as the opposite side and the y component as the adjacent side. So tangent is opposite over adjacent. So we have negative 7.99 all over the y component, which is equal to positive 9.92 meters. So solve our tangent of negative 7.99 over 9.92. So that is equal to negative 38.84. 85 degrees. So again, a little clarification. My angle theta here is measured from the north line or the y-axis to the resultant vector. So that's why I have the x component as the opposite side and the y component as the adjacent side. So we arrive to the answer, which is equal to 38.85 degrees. So that means, so the negative sign just indicates the direction. So the resultant vector r is equal to 12.74 meters, 38.85 degrees west of north. Now let's try to solve this problem 1.6. So a cross-country skier skis 1 kilometer north and then 2 kilometers east on a horizontal snowfield. How far and in what direction is she from the starting point? So let us draw the figure. This 1.6. Okay. First, she traveled 1 meter north and then 2 kilometers east. So insert. Okay. So this is the this is 1 kilometer and this is 2 kilometers east. So we have the starting point here and the finishing point here. First, let me draw a vector for the, so this is our resultant vector. So, ayun lang natin konti. Okay, so we are asked to find how far and in what direction is she from the starting point. So we have the resultant vector here. Now, let us solve for the components of this vector here and here. So, by observation, we know that the vector here has no x component. So, we have the y component only. And another vector here, we do not have a y component here. This is only the x component. So we can say that the y component of the resultant vector, say r, is equal to 1 kilometer due north, and the x component of the resultant vector is equal to 2 kilometers due east. So for the magnitude of the resultant vector, we can directly use the Pythagorean theorem. Okay. So 1 squared plus 2 squared, this is equal to square root of 5, or 2.24 kilometers. And then for the angle theta here, so theta is equal to the arctangent of, so theta, we have the opposite 2 over the adjacent 1. So, arctangent 2, this is equal to 64.43 degrees. So for the resultant vector r, we have 2.24 kilometers, 64.43. So this is east of north. So we have the north as the reference direction, and we are going east. So that is east of north. Or we can also say that the r is equal to 2.24 kilometers. So for the angle, we can subtract 64.43 to 90. So 90 minus 64.43, that is equal to 25.57. And so this is the 25.57 degree angle. So if we are going to use this one, this is north of east. So again, yung last na direction dito, dyan kayo magre-reference. So, for example, east of north. So, from north, so this is that we are going east. And the angle to that is 64.43. So, and another example, if we'll consider the angle here, 25.57, we have east as the reference and we are going north. So, ganyan yung tamang pagsulat ng direction. Now, let's proceed to the last problem for this learning material. So, a jogger runs 145 meters in a direction of 20 degrees east of north. So, this is the vector A. So, the magnitude is 145 meters and the angle is 20 degrees east of north. So, and then for the next vector, 105 meter in a direction of 35 degrees south of east. So, this, the magnitude of vector B is equal to 105, and again, let's have the direction. 35 degrees south, so it's traveling south of east. So, using components, determine the magnitude and direction of the resultant vector C. So, we have resultant vector C here for these two displacements. So, practice problem 1.7. So, for the solution, we have to find for Cx. So, Cx are the x component of the resultant vector C is equal to Ax plus Bx. So, Ax is equal to 145 meters times D. Since that is opposite the 20 degree angle, we'll use the sine function. Sine 20 degrees plus for the B, the x component of vector B, we have 105 meters times, since the x component of vector B is adjacent to the 35 degree angle, we'll use the cosine function. So, cosine 35 degrees. So, this is equal to 135.60 meters. So, we have positive. So, it means it is directed to the east. As for the y component of the resultant vector C, we have cy is equal to ay plus by. So we have 145 meters times the cosine of 20 degrees. And this is positive since we are heading north, or it is along the positive y. So this is correct. And for the y component of vector b, we have to use the negative sign since it is directed to the south. So minus, the magnitude is 105 meters times the, since the y component is opposite the 35-degree angle, we'll use the sine function. Sine 35 degrees. So 145 times cosine 20 minus 105 times sine 35. So this is equal to 76.03 meters. For the magnitude of the resultant, we have so for the magnitude of the resultant, we have r is equal to the square root of 135.60 squared plus the 76.03 squared. So notice that the y component of the resultant vector is pointed upward. So this one here matches with the sign. So r is equal to square root of 135.60 squared plus 76.0. So we have 155.46 meters. As for the angle theta, this is equal to the arc tangent of, so this is angle theta, we have the opposite over adjacent. So this is 76.03 all over the adjacent side, which is equal to 135.60 meters. So theta is equal to 29.28 degrees. And for the resultant vector R, we have 155.46 meters, 29.28 degrees north of east. So now we have finished the learning material. So if you have any questions regarding the topics we have discussed, you can send me a personal message, or we can organize a video call so that we can clarify your answer. So I hope na madami kayong natutunan, and thank you Sir Nolly for this learning material. So bye guys, thank you.